Welcome to MasterCode. Today you are going to learn how to hack Wi-Fi networks step by step from the ground up. This is not a surface-level overview. This is a complete, practical masterclass covering how wireless networks actually work, what makes them vulnerable, the exact tools professionals use, and the commands you need to run in your own authorized test lab. You will learn how to capture WPA2 handshakes, run deauthentication attacks, set up a full evil twin with a captive portal using Airgeddon, attack WPS with Reaver, and use the modern PMKID attack that does not even need a connected client. Every topic is built on real understanding. Not just run this command. But why does this command work, what is happening at the packet level, and what does the defender see on the other side? Whether you are studying for a Wi-Fi security certification, building your penetration testing skills, or just genuinely curious about how wireless security works, you are in the right place. Make sure you have Kali Linux ready, an external wireless adapter with monitor mode support, and your own test network that you own or have explicit written permission to test. Let's go. Before we run a single command, we need to talk about the law. Accessing or attacking a wireless network without explicit written permission from the owner is a serious criminal offense under laws like the Computer Fraud and Abuse Act in the United States and equivalent legislation in every other country. That includes your neighbor's Wi-Fi, the coffee shop network, your employer's production network, and any public hotspot you do not personally own. The consequences include massive fines and years in prison. We are not exaggerating and we are not being dramatic. Real people have gone to jail for exactly this. Everything in this video must only be practiced on networks you own or have explicit written authorization to test. You should set up a dedicated test router at home for this purpose. It costs around $20, you own it, and you can do anything you want to it legally. Keep that router on a separate network segment from your main network. That is your practice range. That is where every demo in this video is being run. Never attack systems you do not own. We are here to learn, to protect, and to build real skills the right way. To hack something effectively, you need to understand how it actually works. So let us break down Wi-Fi from the ground up. Wi-Fi is a wireless communication standard defined by the IEEE 802.11 specification. Your router broadcasts a network name called an SSID, which stands for Service Set Identifier. This is just the name you see when you scan for networks, like home network or coffee shop _free. Devices communicate with the router using radio frequencies, typically 2.4 GHz or 5 GHz bands. The 2.4 GHz band has longer range but gets congested because microwave ovens, Bluetooth, and baby monitors all operate there. The 5 GHz band is faster and less congested but has shorter range and struggles with walls. Data travels in packets called frames. There are three types of Wi-Fi frames. Management frames handle the connection process, beacons, probe requests, association, and authentication. Control frames manage the flow of data between devices. Data frames carry the actual payload, your web traffic, your messages, your files. This frame structure matters for hacking because some frame types, including management frames, can be sent without encryption. That is the foundation of the deauthentication attack you will see later. Understanding the frame types makes you dangerous. It also makes you a better defender because you know exactly what to monitor for in your wireless intrusion detection system. Wi-Fi security has evolved dramatically over the years, and knowing the history explains exactly why certain attacks work. The original standard was WEP, Wired Equivalent Privacy. WEP was designed in 1999 and it was broken almost immediately. The fundamental problem is that WEP reuses initialization vectors, which are the random values used to seed the encryption. With enough captured packets, an attacker can statistically recover the key in minutes. Tools like aircrack-ng can crack WEP keys from a packet capture in under 60 seconds on modern hardware. Do not use WEP. If you see WEP in a real penetration test, that network is compromised by definition. WPA, or Wi-Fi Protected Access, replaced WEP in 2003 using TKIP encryption. It was better but still had serious weaknesses. WPA2 arrived in 2004 using AES encryption and CCMP, and this has been the standard for 2 decades. WPA2 is still commonly deployed and still vulnerable to the attacks we cover today, including handshake capture and cracking, evil twin attacks, and PMKID attacks. WPA3 is the newest standard, launched in 2018. It uses simultaneous authentication of equals, or SAE, replacing the pre-shared key handshake. This eliminates offline dictionary attacks against the handshake. WPA3 also provides forward secrecy, which means capturing past traffic is useless even if the password is later discovered. For your penetration tests, you will most commonly encounter WPA2 personal. That is where most of today's attacks apply. You cannot do Wi-Fi hacking with just any laptop. The built-in Wi-Fi adapter in most computers does not support monitor mode or packet injection, which are the 2 capabilities you absolutely need. Monitor mode lets your adapter passively capture all wireless frames in range, not just frames addressed to your device. Packet injection lets you craft and transmit arbitrary frames, which is how deauthentication attacks work. You need an external USB wireless adapter with the right chipset. The most reliable choices are the Alpha AWS036ACH, which uses the Realtek RTL8812AU chipset and supports both 2.4 and 5 GHz in 802.11 AC mode. The Alpha AWS036NHA uses the Atheros AR9271 chipset, supports 2.4 GHz only but has excellent driver support in Kali. The Panda PAU09 with Ralink RT5572 also works well. These adapters cost between $20 and $50 and are worth every penny. Chipset matters more than brand. The Atheros, Ralink, and Realtek RTL8812AU chipsets have the best Kali Linux driver support. Avoid Broadcom and Intel chipsets for this work. They have limited or no monitor mode support. When you plug your adapter into Kali, run the command uconfig to see all wireless interfaces. Your external adapter will typically show as WLAN 1 since WLAN 0 is the built-in card. If you do not see it, run WSUS to confirm the system sees the USB device, then check that the driver loaded with DMESC pipe grep USB. Once your adapter is detected and the interface appears, you are ready to start. This is the actual chipset compatibility list published by the Airgeddon project for evil twin attacks. The smiley face ratings tell you which adapters work fully. At the top, Ralink RT5572 chipset, used in the Panda PAU07 and PAU09, dual band 2.4 and 5 GHz. Excellent compatibility. Below that, Atheros AR9271, used in the Alpha AWS036NHA, 2.4 GHz, top rated. Ralink RT5370 and RT5372 also get high marks. These are your safe purchases. The Intel and some MediaTek adapters show as circles, meaning limited or no support. When you are buying an adapter specifically for Wi-Fi penetration testing, use this list as your reference. The USB column confirms these are all external adapters, which is what you want. Plug it in, enable monitor mode, run your attacks. No driver compilation, no workarounds. Just plug and go with the right chipset. Kali Linux comes with all the tools we need pre-installed, but it is worth knowing what each one does before you run it. The aircrack-ng suite is the foundation. It is actually a collection of tools that work together. Airodump-ng is the packet capture and network scanner. Airplaying handles packet injection including deauthentication and fake authentication. Aircrack-ng itself is the password cracking engine. Airgeddon manages monitor mode. You also want Hashcat for GPU accelerated password cracking, which is dramatically faster than aircrack-ng on a modern GPU. Airgeddon is a framework that automates evil twin attacks with a captive portal. Reaver and Bully are the tools for WPS attacks. Handshake and Handshakes enable the PMKID attack. To update Kali and ensure everything is installed, run sudo apt update followed by sudo apt upgrade. To install Airgeddon, run sudo apt install Airgeddon. To get Handshake and Handshakes, run sudo apt install Handshake. Confirm your wireless interface is ready by running uconfig. You want to see your WLAN 1 interface showing up. Plug in your external adapter, confirm it appears, and then let's move to the most fundamental concept in wireless hacking, monitor mode. Monitor mode is the foundation of everything. Without it, your wireless adapter only sees frames that are addressed to it, like any normal device. With monitor mode enabled, your adapter becomes a passive listener that captures every frame it can detect in range, from every network, every device, every conversation happening in the air around you. Think of it like the difference between a normal phone call and a radio scanner. In managed mode, you only hear calls meant for you. In monitor mode, you hear everything on the frequency. To enable monitor mode, first kill any processes that might interfere. Run sudo airgeddon check kill. This stops network manager and WPA_supplicant, which would otherwise fight with your adapter. Then run sudo airgeddon start WLAN 1. Your interface will typically be renamed to WLAN 1 mon. Confirm it worked by running uconfig WLAN 1 mon and looking for the words mode monitor. Some adapters let you use IWDEV WLAN 1 set monitor control as an alternative. You can also do it manually with IP link set WLAN 1 down, followed by IWDEV WLAN 1 set type monitor, followed by IP link set WLAN 1 up. When you are finished testing and want to return to normal operation, run sudo airgeddon stop WLAN 1 mon and then sudo system start network manager. Always clean up your interface state after testing sessions. Leaving monitor mode active can disrupt your internet connection until you restore it. With monitor mode active, you are ready to see everything around you. The tool for this is airodump-ng. Run sudo airodump-ng WLAN 1 mon and watch the output fill with networks. The output has two sections. The top section shows access points, your target networks. Each row shows the BSSID, which is the MAC address of the router. Then the PWR field, which is signal power, more negative means weaker signal. The beacons field counts how many beacon frames have been captured. The data field counts data frames, which tells you how active the network is. The CH field is the Wi-Fi channel. The ENC field shows the encryption type, WEP, WPA, or WPA2. The cipher field shows the cipher suite, CCMP for AES or TKIP for older WPA. The AUTH field shows PSK for pre-shared key or MGT for enterprise authentication. And the ESID is the human-readable network name. The bottom section shows stations, the client devices connected to those networks. Each client row shows its own MAC address and the BSSID of the network it is associated with. This list of clients is crucial for deauthentication attacks. You need both the router MAC and the client MAC. To focus on a specific network and channel to reduce noise and capture more data, stop the scan and run airodump-ng with the channel flag, --channel, specify the channel number, then --psid followed by the router MAC address, then -w followed by a file name to write the capture to disk. That file will be your handshake capture file. Keep this running in the background while you proceed to the next step. This is a real airodump-ng scan output from a live authorized test. Look at the top section: BSSID, signal power, beacon count, data frames, channel, encryption, cipher, authentication, and ACID. Every column tells you something useful. Down the list you can see Pixel 5, DAM_RT, Draco, Sami TZ, and right there, MasterCode on channel 9 with WPA2 CCMP PSK. That is the target test network. And below in the station section you see all the client devices associated to those networks. Some are associated, meaning they have a connected BSSID. Others are probing, looking for networks they have connected to before. This is exactly what your screen looks like when you run the scan on your own authorized test lab. Every piece of data you need for the next steps is right here: the BSSID for your Deauth command, the channel to lock onto for your capture, and the ACID to match when you set up your evil twin. Spend time reading this output before you move forward. The more you understand it, the better your decisions will be at every step that follows. Before you can capture a handshake, you need to understand what a handshake actually is. When a Wi-Fi client connects to a WPA2 network, both sides prove they know the password without ever sending it in plain text. This is called the four-way handshake. Here is how it works. The router sends a random value called a nonce to the client. The client generates its own random nonce and uses both nonces plus the password to derive a session key called the pairwise transient key. The client sends its nonce to the router along with a message integrity code that proves it knows the password. The router verifies that code, generates the same session key, and sends confirmation. The client sends final confirmation. Connection established. The critical insight is that the 4 frames of this handshake are captured in plaintext by your adapter in monitor mode. They contain all the information an attacker needs to perform an offline dictionary attack. You take the captured handshake and a word list, and you mathematically test each password in the word list. If I compute the session key using this candidate password and these captured nonces, does it produce the same message integrity code I see in the handshake? If yes, that is the password. If no, try the next one. This is why long, random passwords are so important. A 12-character random password with mixed characters would take thousands of years to crack even on a modern GPU cluster. But a password like password 123 or the default router password from the ISP can be cracked in seconds. You need the client to authenticate or re-authenticate to capture this handshake. That is where the deauthentication attack comes in. You have airodump-ng running, focused on your target channel and BSSID, writing to a capture file. Now you need to force a client to reconnect so you can capture the handshake. The deauthentication attack does this by abusing a fundamental weakness in the 802.11 management frame design. Deauthentication frames are not encrypted and not authenticated. Any device can send a deauthentication frame claiming to be the router, and the client will disconnect without verification. To send the deauthentication attack, open a second terminal and run sudo airplaying Deauth 10 or router_BSSID C client_Mac WLAN1 mon. The Deauth flag specifies how many Deauth frames to send. 10 is usually enough. The A flag is the access point MAC, your target router. The C flag is the client MAC from the station list. If you want to disconnect all clients at once, omit the C flag, but this is more aggressive and more detectable. When the client reconnects to the router, it performs the four-way handshake, and airodump-ng captures it. You will see the words WPA handshake appear at the top right of the airodump-ng window followed by the router BSSID. That is your confirmation. Stop the capture. You now have a .cap file containing the handshake. Every minute that client stays connected and re-authenticates is another opportunity. In a real authorized test, you might wait for natural reauthentication rather than sending Deauth frames, since Deauth attacks can be detected by wireless intrusion detection systems. The cap file is your gold. Guard it and bring it to the cracking stage. Now you have a captured handshake in a cap file. The next step is cracking the password offline. This is entirely computational, no network connection required. You take the file to whatever machine has the most processing power you own and start cracking. The basic aircrack-ng command is aircrack-ng capture.cap w/usr/share/wordlist/rocku.txt. The rocku.txt wordlist contains over 14 million real passwords leaked from the 2009 rocku breach. It is included in Kali Linux and is available compressed in the wordlists directory. Decompress it first with gunzip rocku.txt.gz. This simple dictionary attack tests every word in the list as the Wi-Fi password. For more power, use Hashcat, which uses your GPU and is 10 to 100 times faster than aircrack-ng on a CPU. First, convert the cap file to a Hashcat-compatible format. Run xcaptool with the O flag to output a hash file. Then run Hashcat with mode 22000, which is WPA, PBKDF2, PMKID plus EPOL. Add the rules file flag pointing to best64.rule or dive.rule to apply mutation rules. Rules expand your word list by applying transformations like capitalizing the first letter, adding numbers at the end, or replacing letters with numbers. The combination of a good word list and smart rules cracks the majority of commonly used home router passwords. For passwords that resist dictionary attacks, you can use mask attacks in Hashcat. These brute force specific character patterns. A mask of $D 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 tests every 4-digit number, which covers common. Now we move to a completely different class of attack. The evil twin attack does not rely on cracking a password at all. Instead, it tricks users into giving you the password voluntarily, without them realizing it. Here is how it works. You set up a fake wireless access point with the exact same SSID and MAC address as the legitimate network. You force all clients to disconnect from the real network using a sustained deauthentication flood. Your fake network has a stronger signal, so the client's device automatically connects to it. When the client connects to your evil twin, instead of getting internet access, they get a captive portal, which is a web page that says something like your router firmware has been updated, please re-enter your Wi-Fi password to continue. The user types in their password. You capture it in plain text. Game over. The reason this works is that most users completely trust their device when it says it has connected to their home network. They do not verify the BSSID or check the certificate. They just type in their password when asked. This attack is social engineering combined with wireless interception. It is powerful because it bypasses encryption entirely. You never need to crack anything. The user hands you the password directly. In a red team engagement, this is particularly valuable for enterprise networks with long, complex passwords that would resist dictionary attacks. It works on WPA2 personal and it does not matter how strong the password is. We will build this attack step by step using Airgeddon, which automates the entire process. Here is the evil twin attack flow in a real technical diagram. On the left you have the victim connected to the legitimate access point, shown with a green Wi-Fi signal and a checkmark. The dashed line with an X shows that connection being severed by your deauthentication attack. Below that, the red warning Wi-Fi symbol is your rogue evil twin access point. The victim's device, having lost its connection to the real network, automatically reconnects to your rogue AP because it has the same name and appears to have a stronger signal. Once connected to your evil twin, all their traffic flows to the attacker on the right, who sees emails, credentials, location data, card information, and session tokens. This is not theoretical. This exact flow runs completely automatically inside Airgeddon with a few menu selections. The diagram matches the code step for step. Airgeddon is a comprehensive bash framework that automates Wi-Fi attacks, including the Evil Twin captive portal workflow. Install it in Kali with sudo apt install airgeddon, or clone it from GitHub with git clone followed by the Airgeddon repository URL. Launch it with sudo bash airgeddon.sh. When it starts, it performs dependency checks and tells you if anything is missing. Common dependencies include Hashcat for the access point, insmask for the DHCP and DNS server, LightTPD or Apache 2 for the web server hosting the captive portal, and Sturm for the terminal windows. If anything is missing, Airgeddon offers to install it automatically. Accept the installation when prompted. Once Airgeddon is running, you will see its main menu. The first thing it does is ask you to select a wireless interface. Choose your external adapter, which will be WLAN 1 or WLAN 1 MON depending on whether it is already in monitor mode. Airgeddon will offer to put it into monitor mode for you. Let it handle that. This is the starting point. From the main menu, option 5 or the Evil Twin AP attack section is what we want. But do not jump straight there. Spend a few minutes with the tool's menu structure first. Read what each option does. Airgeddon is a powerful framework and understanding its structure helps you control what it does at each step. When you are ready, select the Evil Twin AP attacks option and let's walk through the full process. This is what Airgeddon looks like when you actually launch it. The iconic splash screen loads with the tool version at the top. Then it drops straight into the dependency check, confirming that Hashcat, insmask, LightTPD, and all other required components are present. If anything is missing, it tells you exactly what to install. After that comes the interface selection screen. Here you can see multiple network interfaces listed, F0 for wired, WLAN 0 for the built-in card, and critically, Welksman with a Qualcomm authorized chipset in the list. That external adapter with monitor mode support is what you select. You type the number, press enter, and Airgeddon locks onto that interface for the entire session. Everything from this point forward is menu-driven. No memorizing commands, no looking up flags. You work through the menus and Airgeddon executes the underlying commands for you. Here is the complete Evil Twin attack walkthrough using Airgeddon. After selecting Evil Twin AP attacks from the main menu, Airgeddon scans for available networks. It opens a terminal showing nearby access points with their BSSID, channel, and SID. Wait about 30 seconds for the scan to populate, then press Ctrl-C to stop and see the full list. Type the number corresponding to your target network and press enter. Airgeddon now has all the information it needs about the target including the BSSID, channel, and SID. It will ask you which type of Evil Twin attack to run. Choose the option for Evil Twin with a captive portal. This is the full credential capture workflow. Airgeddon then asks which deauthentication method to use. Your options include airplaying, which sends targeted Deauth frames, MDK3 or MDK4 which flood the channel with authentication frames to kick everyone off, and WIDS confusion mode for more advanced scenarios. For a targeted attack, choose airplaying. For a broader disconnect, MDK4 works well. Once you confirm your selections, Airgeddon spawns multiple terminal windows. One terminal runs the rogue access point using Hashcat. One runs the Deauth attack to disconnect clients from the legitimate network. One runs insmask providing DHCP addresses and redirecting all DNS queries to your machine. One runs the web server hosting your captive portal. And one monitors for captured credentials. Watch the Deauth terminal. You should see clients dropping from the legitimate network. Watch the access point terminal. You should see clients associating with your rogue AP. The moment a client connects and opens a browser, they get redirected. This is what the evil twin attack looks like while it is actively running. Airgeddon opens 5 separate terminal windows and manages all of them simultaneously. In the top row you can see the rogue access point window on the left running Hashcat, and the attack control window in the center managing the overall flow. The middle section shows the deauthentication attack flooding the channel to disconnect clients from the real network. The bottom left is DNS handling DHCP assignments and DNS hijacking. Bottom right is the web server delivering the captive portal page. And the rightmost window is the credential monitor waiting for a password submission. All of this is happening at the same time on the same machine. When a client connects to the rogue AP and opens a browser, they hit the captive portal immediately. Every component fires at the exact right moment. That is the power of Airgeddon as a framework. It orchestrates a multi-tool attack chain through a single interface. The captive portal is the final piece of the evil twin attack. When a client connects to your rogue access point and tries to reach any website, the DNS configuration redirects all DNS queries to your machine's IP address. Every website they try to visit lands on your captive portal page. Airgeddon includes several pre-built captive portal templates that look like real router firmware update pages. The default template displays a clean, professional-looking page with the router brand name and a message asking the user to re-enter their Wi-Fi password to reconnect after a firmware update. It is convincing because the timing makes sense. The user was just disconnected from their network, so a prompt to re-enter credentials does not seem suspicious. When the user types in their Wi-Fi password and clicks the button, several things happen simultaneously. Airgeddon captures the submitted password and writes it to a log file. It verifies the submitted credential against the real network using airplaying. If the password is correct, the attack stops automatically. All the terminal windows close. The legitimate network comes back online as the Deauth attack stops. The client's device reconnects to the real network, and everything appears normal to the user. Meanwhile, you have the password in a plain text file. You can customize the captive portal to match specific router brands, use a company's internal portal look for a red team engagement, or even create a convincing enterprise login page. The key defense against this attack is user education. No legitimate router or network should ever prompt you to re-enter your password after a firmware update through the Wi-Fi portal itself. This is the moment everything leads to. Password captured successfully. Look at the screen. BSSID, the target router MAC address. SID, MasterCode. Online time, 51 seconds. And right there in the middle, password 123456789, followed by the confirmation that the password was saved to the file evil twin captive portal password mastercode.txt. The attack ran for under a minute. No cracking. No GPU. No word list. The user connected to the evil twin, opened a browser, saw the captive portal page asking them to re-enter their Wi-Fi password, typed it in, and it was captured in plain text. The file is on disk. The attack windows close automatically. The legitimate network comes back online. Everything returns to normal for the user, who has no idea what just happened. In an authorized red team engagement, this is your deliverable, proof that the network is vulnerable to a social engineering attack that bypasses all password strength entirely. This is why password length does not protect you from evil twin. Only user awareness does. WPS, which stands for Wi-Fi Protected Setup, is a convenience feature that was supposed to make connecting devices easier. It has become one of the worst security decisions in consumer Wi-Fi history. WPS allows you to connect to a network by pressing a physical button on the router, or by entering an 8-digit PIN. The PIN method is where the catastrophic vulnerability lives. The 8-digit PIN is not verified as a whole unit. The router validates the first 4 digits separately from the last 4 digits. This reduces the attack space from 100 million combinations to just 11,000, a reduction of 4 orders of magnitude. This brute force vulnerability was first published in 2011 and is still present in millions of routers today. The tool for WPS pin attacks is Reaver. Put your interface in monitor mode, then run sudo reaver iwlan1mon b router_bssid vv. The vv flag gives verbose output so you can see each pin attempt. Reaver tries one pin every few seconds to avoid lockouts and typically cracks WPS in 2 to 10 hours depending on router speed. An improved attack called Pixie Dust attacks a specific class of routers that use a predictable random number generator. Instead of brute forcing all pins, Pixie Dust recovers the pin in seconds. Run it with Reaver iwlan1mon b bssid vv k1. Not all routers are vulnerable to Pixie Dust, but enough are that you should always try it first. The defense is simple: disable WPS on your router entirely. Go into your router admin panel and turn it off. There is no legitimate reason to keep it enabled on a production network. This is a real Reaver WPS attack running against a D-Link 605L router. You can see the WPS manufacturer information being extracted at the top: D-Link Systems, Model 605L, serial number. Then the cryptographic exchange begins. Reaver sends the first half of the pin, receives the router's response, sends the second half, and checks the result. You can see the enonce and enonce values, the PKR, the authentication key, and then the failure response, EAP fail. The tool moves to the next pin and tries again. Each attempt takes a few seconds due to the rate limiting built into the router to prevent brute force. What you are watching here is Reaver systematically eliminating pin candidates. Some routers respond to every attempt cleanly. Some introduce longer delays. Some lock out entirely after a number of failures. The tool handles all of this automatically. For routers vulnerable to Pixie Dust, this entire process collapses to a few seconds because the cryptographic weakness in the nonce generation allows you to compute the pin mathematically instead of guessing it. The PMKID attack, published by Jens Stube in 2018, changed Wi-Fi security research in a fundamental way. Every previous WPA2 attack required capturing a 4-way handshake, which meant waiting for a client to connect or forcing a deauthentication. The PMKID attack extracts all the information needed for an offline dictionary attack directly from the access point itself, with no clients required at all. Here is the technical detail. When a client associates with a WPA2 network, the access point sends a key derivation material value called the PMKID in the first EPOL frame. This PMKID is derived by taking the HMAC SHA1 of the string PMK name, plus the access point MAC address, plus the client MAC address. The PMK, or pairwise master key, is itself derived directly from the password. So if you have the PMKID, you can test password candidates offline, compute the PMK from a candidate password, compute what the PMKID should be, compare with the captured PMKID. Match means you found the password. To run this attack, use hxdumptool to extract the PMKID. The command is sudo hxdumptool o output.cap iwlan1mon enable_status equals 1. Run this for a few minutes to capture PMKIDs from nearby access points. Then convert with hxcaptool o hash.hc22000 output.cap. Then crack with Hashcat using mode 22000, Hashcat m22000 hash.hc22000 wordlist.txt. The PMKID attack is faster to set up and requires no client presence, making it the preferred first step in authorized Wi-Fi assessments today. Now that you know how attackers think, you can build much stronger defenses. The most important control is your password. Your Wi-Fi password should be at least 16 characters, completely random, using a mix of letters, numbers, and symbols. Use a password manager to generate and store it. A random 16-character password is not practically crackable even with the PMKID attack and a modern GPU cluster. Enable WPA2 if all your devices support it. WPA2 eliminates offline dictionary attacks against the handshake by using the SAE protocol, which provides forward secrecy and resistance to passive eavesdropping. If you cannot use WPA2, use WPA2 with AES only. Disable TKIP. Disable WPS immediately. Go into your router's admin page right now and turn it off. There is no scenario where WPS is worth the security risk. Use a separate guest network for devices you do not fully trust, including smart home devices, IoT gadgets, and guest phones. This provides network segmentation so a compromised IoT device cannot reach your main computers. Detect evil twin attacks by watching for duplicate SIDs in your environment. Some enterprise wireless systems have built-in rogue AP detection. At home, you can use a phone app like Wi-Fi Analyzer to see if your BSSID ever changes unexpectedly, which is a sign that a rogue AP is operating on your network name. Change your default router admin credentials immediately. Most home router compromises do not involve Wi-Fi cracking at all. They involve attackers logging into the router admin panel with admin/admin or admin/password. Change those defaults the day you let us do a complete tool summary so you know exactly what to install and what each tool does. Airgeddon manages monitor mode on your wireless interface. Airodump-ng scans for networks and captures packets. Airplaying sends packets including deauthentication frames and fake authentications. Aircrack-ng cracks WEP keys and WPA pre-shared keys from captured handshakes. Hashcat uses your GPU for dramatically faster password cracking with rule sets and mask attacks. Xdumptool captures PMKIDs and EPOL frames directly from access points. Xdumptool converts capture files to Hashcat-compatible hash format. Airgeddon is the all-in-one evil twin and captive portal framework. Reaver performs WPS pin brute force attacks. Bully is an alternative to Reaver with better success on some router models. MDK3 and MDK4 perform various wireless denial of service attacks including beacon flooding and deauthentication floods. Wireshark lets you analyze captured packets in detail and is indispensable for understanding what is happening at the frame level. The wireless-specific filter in Wireshark is WLAN, and you can filter for specific frame types using WLAN.FC.type = 0 for management frames or WLAN.FC.type = 2 for data frames. All of these tools are pre-installed in Kali Linux or installable with a single apt command. The Alpha AWS-036ACH and AWS-036NHA adapters are your hardware workhorses. With this toolkit, you have everything a professional Wi-Fi penetration tester uses on real authorized engagements. A professional penetration tester does not just attack. They also understand how defenders detect their attacks. Knowing what a wireless intrusion detection system sees makes you a smarter attacker and a better defender at the same time. Deauthentication attacks generate a very distinctive signature. A normal network might see a handful of deauthentication frames per hour as devices naturally roam or disconnect. During an attack, the WIDS sees hundreds or thousands of Deauth frames per second, all with the same source MAC address. Enterprise wireless controllers from Cisco, Aruba, and Ruckus flag this automatically and can alert the SoC within seconds. Monitor mode scanning is also detectable. Passive scanning does not generate traffic, but tools like airodump-ng still send probe request frames from the adapter. The channel hopping pattern of airodump-ng, rapidly cycling through channels every 100 milliseconds, is recognizable to an experienced analyst. Evil twin attacks generate two signatures. First, a duplicate SSID with a different BSSID appears in the wireless survey data. Enterprise APs actively survey for rogue access points and flag duplicates. Second, the deauthentication flood that accompanies the evil twin attack shows the same burst pattern described above. During an authorized red team engagement, you should assume your wireless activity is being monitored. Test your attack timing. Use minimal Deauth frames. Spread your reconnaissance across multiple channels and longer time periods. Use a MAC address that blends in with the device types on the target network. The goal of a professional penetration test is to show the client what a real attacker could do, which means being as stealthy as the most sophisticated real-world threat actors. Here is your practical roadmap for building real Wi-Fi hacking skills legally. Step 1. Buy a second router. A used TP-Link or Netgear router costs $15 to $20. Set it up in your home on a separate segment. That is your target network. Never run these attacks on any other network. Step 2. Get the right adapter. The Alpha AWS036ACH is the best all-around choice for Kali Linux. Confirm it enters monitor mode correctly on your system before going further. Step 3. Run through each attack in order. Start with passive scanning using airodump-ng. Learn to read the output completely. Step 4. Capture your own WPA2 handshake. Connect a phone to your test router, then capture the handshake using airodump-ng and a Deauth attack. Crack it with aircrack-ng using rocku.txt. Set a weak password on the test router first so you can confirm your cracking workflow is correct. Step 5. Run the full PMKID attack workflow with XDumpTool and Hashcat. Compare the speed difference between CPU cracking with aircrack-ng and GPU cracking with Hashcat. Step 6. Run Airgeddon against your own test network. Build an evil twin, set up the captive portal, and capture your own credentials. Do all of this on your own network only. Step 7. Enable WPS on the test router and run Reaver and Pixie Dust. See which attack succeeds on your specific router model. Document everything. Write notes for each attack, the exact commands, what succeeded, what failed, how long it took, and what the detection signature would look like. That document, you now have a complete understanding of Wi-Fi hacking from the ground up. You know how wireless networks work at the frame level, how WPA2 authentication is structured, how to capture handshakes and crack them offline, how to build an evil twin attack with a full captive portal, how to exploit WPS, and how to use the PMKID attack that requires no client at all. You know what the defender sees and how to think about detection. This is not a simple topic and you made it through the whole thing. The next step is practice on your own test network. No amount of watching makes up for actually running these commands, seeing the output, understanding why something fails, and figuring out how to fix it. That hands-on time is where real skill develops. If you want more from MasterCode, the full Ethical Hacking series covers networking, Linux, Python scripting, web application security, professional tools, CTF competitions, bug bounty hunting, and security research. All linked in the description below. Smash the like button if this video helped you, subscribe for more, and drop a comment with what you want to see next. I will see you in the next one. Keep hacking legally.